Hello everyone, once again welcome to my YouTube channel, The Learning Hub. And in continuation with the AML tutorials, today we are going to discuss about entropy and information gain in decision trees. So let's firstly discuss about what is entropy. So when we talk of entropy, basically entropy is nothing else. It is just a measure of these things, that is uncertainty. So we are having any uncertainty in the data. Purity, it is a measure of how pure our model is and how pure we have got the results. And information content, information content. So when we talk of entropy, it simply means it is a measure of uncertainty, purity, and information content. So basically this gives the error rate, you can say. It can be helpful in estimating that, like, because it will tell us how much certain we are about some information and what is the level of uncertainty in that. It also gives us how much purity is there in the data set and how decisions are being taken when we talk of decision trees. So as we have already discussed, that decision trees are there to do CART, that is classification and regression trees, which means it can be used for classification as well as for regression. So in that, entropy will give us the measure of all such things. So when we talk of entropy, let's have a look at the formula for entropy. Now suppose we want to calculate entropy of S in this case. So we will use the formula, in this case minus positive values divided by, so here positive values divided by total number of elements minus into log 2 positive values divided by n minus, now we will take the negative values, so negative values divided by total values log 2 negative values divided by n. So this is how we calculate the entropy, which gives us the measure of uncertainty. Now suppose in an example we have total 10 records. Out of these 10, positive categorical variable we are having 7, and negative values we are having 3 in this case. So total 7 plus 3 is 10. Now how this, what will be the entropy of this? It will be positive values are minus 7 oblique total number of values are 10 log 2 7 oblique 10 minus negative values are 3, so 3 oblique 10 log 2 3 oblique 10. So this is how we calculate the entropy. So it will give the values of uncertainty. Now when we talk of information gain, so when we talk of information gain, basically it will be known as reduction in entropy, because entropy is measure of uncertainty. So basically it is reduction in entropy after choosing any attribute A. Suppose we are having 5 attributes, that is the properties of something, and after choosing any of the attribute, how much entropy is reduced is known as information gain. So we write the formula for gain as S of A may be any attribute. It is equal to entropy of S, that we have discussed how it is calculated, minus summation of S of V divided by S into entropy of SB, where the value of SB, basically these belongs to all the values of A. Now suppose we are considering an example in which we calculate the values for this, and we are having attributes like the attribute is outlook, or it may be temperature. So all these values will go here, and entropy is simply whether someone will play tennis or not, based on that. So we will calculate that entropy first, then from entropy we will subtract the addition of all the values s of v, where s of v belongs to each of the value, divided by s, that is total number of values in that case, multiplied by entropy of each and every value in value for that attribute. So this is how we calculate information gain. And when we talk of gain, it will give us the root node on which we have to split the tree. So information gain, if the information gain is higher, we are talking about that it is this attribute is giving the maximum information. So that is known as information gain, and that information gain will support us to decide that this is the best node or best attribute to the to make a suppletion. Now suppose we are having attribute age, we are having attribute weight, and we are having any other attribute, let us say xyz attribute, any other attribute, and this is having information gain 3.2, this is having 4.1, and this is having at 2.0. so now information gain of weight is the highest one. It means it will be chosen as the parent node, and based on that we have further separation. So this is how information gain is playing the role in deciding these things. So that's all about information gain and entropy. Now we have understood about information gain and entropy. We will use these two formulas, two important parameters for solving the numerical problem in the next video. Okay, so just wait for the next video and subscribe to my channel so that you don't miss that important video, and you will get to know how to solve the problem of decision trees, how we will create a decision tree. So thanks for watching the video.